see my screen?
Yes, it is visible.
Okay, fine. So from today onwards, we'll start with the Spark classes, and I will share you the syllabus in the group. Okay. So okay. So for today, like we'll have an introduction. So anyhow, it's a little late. So we'll have introduction. From tomorrow onwards, I'll give you the details. This would be around take maybe it might be 10 to 12 hours of session. Okay, we'll try some important topics in that class. Okay. Where it is. Notepad. Yeah. Okay. So, again, this were only the introduction, right? We'll try to understand today, like, what exactly the Spark is. It's even like it's a little related to a Hadoop one. So, as we discussed, like this MapReduce and Hadoop. So it's one of the big data framework, and we'll see one of the key features and benefits of this Spark and the core concepts and some advanced topics. I will discuss it later. And, okay. Okay. For today, okay. So, what is Apache Spark? So generally, it is one of the Apache related uh, product. So we'll see what is Apache. And okay, even I think I need to install the setup and I will show it. Okay. So here, like mostly Apache, we can use it with this any one of the programming language, either with the Python or with the Scala. So this Spark Emlib machine learning maybe. So this Spark we use mostly in the this machine learning. So we will see like how we can use those machine learning concepts in the library, which one, and even we can use this Spark SQL. Okay, so we learned this Hive SQL, right? So just like that only. So we don't need to focus that much here because anyhow we covered those topics over there. And PySpark, I told you, right? So Spark, we'll see. Okay, we'll try to understand difference between PySpark and versus Spark.
पता बोर्ड है
Okay. And okay, it's better. There is one concept called the Spark data streaming. Streaming data. Yeah, this would be fine. Okay. So generally, this Apache Spark, it will be used in either machine learnings, AI, and even this data engineering also. So um, this is one of the computer framework. Like framework is nothing but like instead of like, for example, it's just like a, what would I say, um, a supermarket. So if you want to buy something, so uh, so you want to purchase something, and you're purchasing one item from one place and one item from another place. Instead of that, if you go to any supermarket, you can find all the products at the same place. Just like that only. It's one of the framework where you can create uh, framework for the what we say, big data processing. Means to handle large data sets and to process this data, we use this we use this Spark. Okay. So generally, either it can handle the both batch jobs and the streaming jobs. Okay. Compared to this, as we discussed, right, this high-end controller, this is far better actually, because um, with the high efficiency and performance it can handle. Okay. Okay, and so if I see in the simple one, so as we know, right? So this Selenium or the Cypress, or there are some tools. There are some frameworks which can be used for the automation purpose. So this is one of the framework where it can you don't need to use multiple technologies to process the data. Okay, just a second. So compared to others, so this Spark, it has the in-memory means. So, for example, you're running out of the memory. You don't need to add anything. So it will add the memory how much it is required. Significantly, it's faster the processing speed. Okay, compared to the disk spaces system. In simple way, for example, you started running one process. So in normal disk spaced, so in the disk spaced based systems, so there is some dedicated memory you might see. Means maybe if it is allocated with maybe 10 GB, so it's a fixed one. Whereas in this in memory, so how much memory it is required, it will add on its own, and it will process the workloads. Okay. That's the one thing. And it is a fault tolerance. Means, for example, mostly if you take any another technologies, there might be chances of the failures. Okay. So where this one, um, it will automatically recover from another node. Okay. Or I can say it's what are the task failures we have. like it will try to fetch the data, okay? And even like we'll try to cover, I will try to cover this API concept too, okay? One day we'll have this API session where I will show you what exactly API is, so it will be useful. And I will try to trigger on API, okay? So even like Spark can include a lot of APIs, okay? So API is nothing but we'll pass one of the link. Through that link, we'll try to gain the access to the servers and get the required information, not the entire information. For example, I have this many keys. So whenever I request for any data, the normal way, it will take all the data out of it. It will filter out the required information. So that is the normal method. Whereas in the API one, so we will pass one URL, the link, where it will go to the server. In this server, it will fetch for check for the required data. If it is there, it will only process this data only. So by this, we can improve and we can speed up the process. Okay. So this normally this can be done in the Scala, either Java or Python, or you can use this R also. Okay. Um, so this Spark we can integrate with, actually this is Spark is separate, one of the separate concept. So we can integrate with this Hadoop and we can work it, okay? Okay, this one. So actually, if I want to show it, I need one of the tool, but this is another one. So this is another laptop, so I don't have that one. So I'll try to install the software and I'll show it to you. Okay. So generally we discussed right in the Hadoop, we have this HDFS and all. Okay. I'll show it in the Excel. That would be easy for you. Mhm. Okay. 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 We'll discuss it here only. In generally we discussed right. We have in the Hadoop we have this HDFS and the MapReduce. So the generally these two will drive the this entire Hadoop, and even we can do this batch processing, right? And what else we can do? Um, Even this Hadoop also it can be scalable, like a fault tolerance, and it can do the large scale of data processing, okay, and storage also. But compared to this Spark, it is a little slower. Candy. Okay, so where we already discussed it. So compared to Hadoop, this Spark is in memory. Like we can uh, in the real time we can do the processing. Like this Hadoop, we can do only the batch processing. Whereas in the Spark, as I told you, the real-time data means whatever the data is reflecting over in the here, it it will be processed. Okay, that's the one thing. And the workloads, I told you, right? Workloads are nothing but either you can take this Hive and all. So these workloads are huge. So it can be handled easily, and even it can have this API model. And so mostly, I would say Spark is generally faster than the Hadoop. So that's why most of the projects they use this Spark only. And it's if you get into any one of the project, either they might use this Spark or Hadoop. Okay, so or else like for example, if I take any project, so then even they might use this both because wherever these are applicable, they use based on it. Okay. I would say like this Spark generally it is more flexible for the programming compared to the MapReduce because here we are using this MapReduce. It is a little complex compared to this Spark one. So mostly, uh, I told you right. Spark, PySpark, we have PySpark in the Azure. Right now in the market, we have the good reputation. So there are a lot of openings. So PySpark is one of them. So use cases, I would say, it do the real-time processing and even it can be used for the machine learning and graph processing. So we seen some of the graph data, right, about these dashboards and the reports. So that kind of data also we can do the processing. Okay. Okay, in the Spark generally, there are some concepts I would will discuss core concepts related to um, R RDDs. RDD is nothing but resilient distributed data. So, and even we'll see these transformations and actions and Spark SQL and frameworks, data frames. So data frames is nothing but actually in the PySpark, how we use, I'll say you. This will be easy if you know at least the basics of the Python. So they use a combination of a Python and SQL and the Spark. Spark means some of the Spark libraries. So libraries is nothing but it's a group of functionalities which store somewhere. So that can be reutilized in this Python. Okay. And the Spark string. Okay. Um, okay. For now, we'll discuss about this one, the resilient data set. Okay. So So generally these are related to a Spark where it's kind of a fundamentals, okay? So where like I would say, so whatever the data we are storing in the Spark, for example, I store some data somewhere. I want to access it. It can be done in the parallel, okay? So it can be operated in the parallel way. And I would say they are the collections of the immutable, okay? So I would say what is meant by immutables means once the data is stored, it can't be changed, okay? So, okay, we'll see the key characteristics. First one is the immutable. So I told you, right? So once it is created, it can't be changed. What is that one? RDDs cannot be modified. So for the sake of your example, I will show you one RDD, and I will explain it to you. So that would be easy. And distributed means whatever the RDDs we are storing are partitioned. Means so if you want to store some data, it won't store in the single place. It will be partitioned and distributed across multiple nodes in a cluster. What is meant by cluster? Cluster is nothing but a group of. So cluster, I would say it's a simple group of the similar things. For example, some data I'm doing the processing. So that data will be whatever the related data we have that is processed in the single cluster only. Means so there are some group of machines or servers we have that will execute all the related jobs. So those comes under this cluster only. So in this cluster also we have multiple nodes. Okay. And this one is the resilient. Resilient is nothing but whatever if there is something happened and the job is failed, it will automatically recover the lost data. Okay, we don't need to worry about it. And even it can do the evaluation. Means it will do the transformations on non-executed until an action is triggered. Means for example, I have one job I want to. So it has to be triggered. If it is not executed, so whatever action, like for example, it has to be informed or there might be some action I have to take care. Means I need to cancel that one. Or example, I need to re-trigger manually. So until you are taking any action, it will not be executed. Okay. It will keep on hold. And even for the tracking purpose, this is easy. So um, I'll try to show you. Mm, okay. Uh, we'll try to. What are the transformations we use in this Spark? I will say. Uh, so mostly whatever we already have in the created RDDs only, we reutilize from the existing ones. Okay. So for example, if you're working in any project, so you don't need to build it from the scratch. So what are the existing RDDs you have the already created? You can utilize the existing ones only. Okay. So example map, filter, flat map. So I'll try to cover this in the further class. Like we already discussed this, right? Group by and join union. So these are related to SQL actually. So we are reutilizing here. And this map, filter and flat map, I will cover it in upcoming classes. Actions triggers the execution of transformations. So whatever I am creating here, the transformations, initially how this works, I'll say. So generally, initially they will create some transformations here. On top of these transformations only, what I'll do, I will create some actions. So if I'm having this union, so what action I need to take care. So that kind of actions will here. Examples like collect, count, reduce, first, take. So for example, so I'm applying this join transformation. Let's take I'm joining maybe two tables. Once the join is completed, I need to collect the data. So collect generally used for the collecting the column names of the data. So we'll collect the data and we'll pass it somewhere. So generally, I'll show you the example code. So this is how it's look like. Now let's take val. Val means the value. I'm saying I'm giving one object means I'm creating one object called numbers, that is a val, and I'm applying the value. What is the value? Let's take lies. Let's say three. Right. So what happened here? Val double numbers equal to numbers dot map. So whatever the value I have, I'm using this one, I'm doing the doubling of this value. Means underscore into 2. So whatever here I have, it will be multiplied with this 2 and the val sum. Sum means whatever the multiplied value, I'll just add here. Underscore plus underscore println. Println is nothing but, yeah,
Can you explain it again?
sorry.
I did not understand. Can you explain it again?
Okay. Okay. So generally, this RDD whatever we have, RDD is nothing but we'll try to create this data sets. Data sets are nothing but so we'll try to pass the existing data in the database here using this RDD. So I'm just taking one example. Like for example, um, I'm taking one sequence. Let's take 1, 2, 3, 4, 5. This we are returning in the Scala. So generally RDD how it works means initially we
Is
will
this the Python syntax? What syntax is it?
yeah like generally we are uh, so this course is related to Spark. In the Spark either we can use a Python or you can use a Scala. So
Okay.
so Spark is nothing but it's a kind of framework like okay. So frameworks. You can go back and see, like even we have many frameworks, Catalan, uh, this Visual Studio, Visual Studio, this one. And in these frameworks, initially we need to configure this Spark, where it is, the Spark one using this Python or Scala.
Okay.
Uh, for example, in your project, I told you, right, we'll be having this batch processing and real-time processing. For the batch processing example, you are using this Hive, the Hadoop one. So where you will already have the data somewhere on top of it. Uh,
Like, what is the connection between Hive and this Spark?
Hive, like it's used for the batch processing, whereas this Spark, it is used for the real-time data. Means whatever you are writing the code, when the code is started and till the executed, the real-time data will be processed here itself and the data will be stored somewhere. So you don't need to go back
Okay.
and check the data in any storage or something. So you know about this dynamic and static concept, right? Static is means the remains same or it's a fixed one. Dynamic is nothing but it's a variable means it will change according to the situation. So let's consider this Hive. Hive is related to a static means it's only do the batch processing. So what for the batch processing, for sure we need to have any kind of storage data or storage space. For this dynamic, like whereas in the Spark, we don't need any database. So that like it will temporarily store this data somewhere and it will apply the logics whatever we are applying and it will give the results. So that's how this Hive works actually, Spark works actually.
In Hive, we did all the SQL operations, right?
Yeah.
So here, like, we are connecting this Spark and Hive, right?
No, actually, in the Spark, we use the combination of Python and SQL. So, to
Okay.
understand this Spark, you need to at least have the minimum knowledge on the Python. So, in between,
Yeah.
if I'm writing some code, I will explain you the Python code also. So, you will understand a little bit.
Okay.
So, for now, like I'm writing this Scala, even I'll write it in the Python also. So, for your understanding.
Okay.
Spark is used for both the batch and real-time process, right?
Spark, no, we can't. Spark, we can. It won't do the batch processing. It's efficient in the real-time processing.
Even though it's efficient in real-time processing, it will do the batch processing, right?
No, actually it won't do.
Well,
So
then
generally, this Spark will don't have any storage space. Means it won't store any
it will
data.
use HDFS storage.
Yeah, yeah,
Then
somewhere
why?
like Spark, it's dependent on again the HDFS one. So it can
Yeah,
take the help of Hadoop components and it can work. So that's how in the combination it can work, but not in fully.
I think Spark is used for batch processing also.
Yeah, we can use it. Spark. We can use this Hadoop components and we can work on it.
Yeah,
But mostly they use it for the real-time processing only, the Spark one, because um, uh, so whenever we are using this batch processing, right? Anyhow, we have this Hadoop. So in that we have this Hive concept. So they will route that related on. Means for example, according to your needs, they will do this. If I say, let's take in my project. So
can use SQL in Spark also, right?
yes, yes, from both SQL can be used anywhere. So in the
Then
Spark,
why on? Then all the high SQL queries can be written in Spark also.
yes, correct. So, but the format
What's the
or
then what's the main use of Hive?
Hive mostly it is used for the batch processing actually. So
Yeah,
and it's moreover compatible with the Hadoop. So there is example. Let's say there is some project they have some limited budget. So they will only go with this Hive because it's a part of this Hadoop ecosystem. Whereas in some
yeah.
project,
Spark is also on top of Hadoop. On top of Spark only we have Hive, all those things, right? So Spark is also compatible with the Hadoop, right?
yeah,
Just it is placing the MapReduce.
yes.
Then we can use SQL queries in the Spark also, right?
Yes, correct. But not individually. We actually, it's a combination of Python and SQL. So in the Python, we will call this SQL, SQL queries.
Oh,
I still did not understand the process of Spark. Like, what is it doing? Why is it doing it? What is the process actually? I'm still able to understand.
Okay. So generally, uh, Spark, even it's one of the big data concept only. Like, I would say mostly it's used for the distribution processing. Like, let me show you. I should have the picture, but actually not this one. So this one is used for the distributed processing. For example, the data will be stored somewhere and it will be, uh, I think I can show it. Okay. Wait, this one, just a second. Actually, I lost my documents. Yeah, this would work. So you're able to, okay. You are able to see, right? This Spark. So this Spark,
Yeah, yeah.
it can interact with all the databases like, where, okay. Just a second, I'll open this one. Yeah. So whenever you want to process some data, what the difference exactly means, this Spark one, In the Hive, we can't create the data frames. In the Spark, we can create it. So I'll tell you further. So data frames are nothing but in a it's kind of serial programming where step by step we'll written in the Python. So where we'll process some data and we'll interact using this SQL queries to the Spark. So Spark generally what it will do means uh, if you are getting the data from different places, it will integrate here in the Spark itself and it can do the processing and again it can do the distribution. So that's how it
So
works.
it does batch processing.
Batch processing, it can do batch processing, we can do it. Moreover, we use it, this for the real time. Like for example, you see this MongoDB, right?
Yeah.
MongoDB, it's kind of an unstructured database. So,
Okay.
or you can take this Postgres. So we are getting the data continuously. This is related to static data. Streaming data is nothing but you are getting data continuously from here. Maybe not
Hmm.
here, from maybe social media sites from where you are getting the
Okay.
data. So where Hive can't use it, uh, it only it can only work on this data, means the static data, where this one can work on both the datas, both streaming and the static, means the batch processing.
I mean, the Spark can work on both the data.
Yeah, it can. So
And
actually,
in the output, what will it do?
in the outputs, uh, in a similar term, whatever the data you are getting, either you can, generally what happens in the real projects, you have one database. It can be either used for the same, like input and output as well. If you see here, where it is, this Cassandra, here we have this Cassandra and the Kafka also we have. Means you can read out the same data to here.
Sorry.
Uh, so you're able to understand this one. Like generally, this Spark, if I say in the simple terms, Hive, we need to use this MapReduce. Here also we can use it. But whereas in the Hive, Spark, we can't use this machine learning. Means we can't give the data set to the machine. So whenever you are writing this one, you don't need to interrupt every time with the programming. Like once you give the data and you will say the actually in the Spark the plus point is you will say the Spark like you will pass some data, you will train it like whenever you are receiving some kind of data, you need to react with this kind of with this kind of information. So that's how we can use this Spark. Actually, um, we can train a data, means let's take we have large data sets from where you are identified some patterns. So that I be done in the Hive. So that's why we use this Spark one. So um, we have this advantage with the machine learning library, where like we'll pass some data and we will train the uh, this part, like saying whenever you're receiving this data, you need to understand and you need to identify some pattern. According to that, you need to react. That's how it can be done. Yeah, this was I was saying about the RDD Spark.
But usually machine learning will train the data and do the modeling, right?
Yeah. So for that,
Either it predicts or it classifies the data, right? So what will Spark do with the trained models?
no, like with it, initially we won't have any data. So whatever the data we are requesting, based on this data only, we'll train the models.
Okay.
So actually, to understand the ML, like it has to get lot of data. So initially, for example, you know some words. Based on that words or the letters, you can form some words or the sentences. If you know
Yeah.
more information about if you have more letters or more words, you can form.
Yeah.
So that's how this ML works. Um, Actually, I'm not using my laptop. I should have this PPT with me. Like by tomorrow it will be resolved. Like tomorrow, like we'll start freshly. Okay.
Okay.
So like for today we'll stop it here. Like tomorrow, like we'll have a class. Okay. Same time only we'll start around 8 o'clock. So mostly like
Sure.
we'll start freshly tomorrow.
Okay.
Okay. Yeah.
Thank you.
Yeah. Thank you.